While doing my demonstrations with a spinning bicycle wheel and a spinning wheelbarrow wheel, I wondered what would happen if instead of a rigid spinning wheel, I had free swinging weights. So I started investigating, see if I could come up with a way to check that out. So I'll show you what I did. My wife thinks this thing looks like a carnival ride. I think it looks like a devious weapon the Green Goblin invented to defeat Spider-Man. But neither one's true. The whole idea is to simulate a spinning wheel type gyroscope with independent weights, segmented weights, to see what happens when they can move around. Would it behave the same? Okay, let me show you how this thing is made. First of all, the center hub here is a mountain bicycle hub I purchased off Amazon. I had to loosen up the bolts holding the bearings in a little bit so it'd spin more freely. This is, I think it was the front, I believe. It doesn't matter, you could use either one. I drilled out these holes, 6 of these holes, because I had 6 of these weighted balls here, to the right size to get these quick links in there. Just 6 stainless steel quick links and just some regular steel chain. And the reason for using the chain is I need to get this distance to be as close to being the same on each of these as possible. I thought the uniform size of the chain would help. It does seem to. The reason for these connectors here is but I didn't have those in originally. If I'd spin this thing up, all these things would swing to one side. It just plain didn't work. So I put those in, that helps hold them apart. These are weighted training baseballs. They got a rubber shell. They're filled with an iron powder to about 16 ounces. And I just drilled a hole in them to put a 1/4 inch eye bolt in. And some of the powder fell out, and I put them on my top loading balance and had to add a little sand to some of them, get the weight back to try to balance it. And I've got just a double nut here. The outer nut is a locking nut, but I've got everything movable locked down with cyanoacrylate or super glue. These and those, all those, and all these nuts and things I've got super glue on them. I don't have it there because there's not as much of the risk of that coming loose. This is just 3/8 threaded rod, a 3/8 connector. This is all metric on this bicycle hub. I didn't have the right metric parts, so I drilled out half of this connector to the right size to fit over this one of these axle shafts, and then just glued it in there with JV Super Weld. That way I could just thread this threaded rod, this 3/8 threaded rod on this end, and lock it down with a lock washer and a nut. The other side's the same thing, it's just a little shorter and ground to a point, so I could see if this thing would spin like a top. So we're going to take it out and give it a try and see if it works. You recognize this from my other video on making a spinning wheelbarrow tire kind of spinning top gyroscope. This were made to engage the wheel on that. Now I had to modify this hub a little bit. I put 2 little stainless steel bolts in here, and I found this in my pile of stuff, just a connector. These little recesses here happen to be just right to engage on those little stainless steel bolts, and this will just fit in there like so, and I can use this to spin it up. I'm going to run this experiment outside. Those spinning baseballs, if they get loose, could do some damage. I wish I had some baseball catcher's gear, but I don't, so I'm going to wear a face shield since I don't have that for some level of protection. First thing I'm going to do is see if this thing will spin up and see if it will balance itself like a spinning top. We're going to give that a try first. To get a better look at what happened, I'm repeating this last clip in slow-mo on the iPhone 12 Pro Max, 240 frames per second, 1080p. You can see the balls are swinging, pretty much staying in the same plane, spin plane. The axle shaft is not exactly perpendicular to the plane the balls are spinning in. I'm going to let go of it here and watch what happens. The balls will continue spinning roughly in the same plane, but the axle shaft goes way over, a lot faster than the balls do. That would not happen with just a rigid wheel type of spinning wheel arrangement, because it's fixed. The axle shaft is always 90 degrees to the spinning wheel. Not the case here. Now, to make sure I didn't accidentally miss something, I've repeating that last slow motion clip. If you'll watch, after I spun it up, I'll grab the spinning ball device, trying to very carefully move it so that I don't, so I leave the balls in roughly the same plane, which is close to being perpendicular to the axle shaft. Probably wasn't exactly perpendicular to the ground, but it's pretty perpendicular to the axle shaft. Now, as I move it over to set it on that block, those balls start slightly changing plane. Now, if you watch, as it's spinning on the block, I'm trying to feel it and see if it's going to stabilize itself. No matter what I do, I don't get that feeling. I angle it one way, there's a lag time. If I angle it, say, one direction, there's a slightly lag time before the balls go there. You wouldn't have that in a rigid spinning wheel arrangement, but you do in this. And what happens is when the shaft, axle shaft, gets at a pretty significant angle to the spinning ball plane, it's actually pulling the balls in the direction that where it's angling, because there's less distance to the radius of the axis. So it basically defines a slight oval. So again, this is all experimenting, because I didn't know what was going to happen when I tried this. And so I kept messing with it, trying to get it to stabilize so I could let go of it. And it really just looked like it wasn't going to do it. So finally, I let go of it and it crashed like before. So this is not going to work for a spinning top, at least not this device. To show you how easily you can use just a wheelbarrow tire wheel as a spinning top, we're going to spin this up. This is in an earlier video. You can go back and look at it. But you'll notice, and if you watch this, the axle shaft stays exactly perpendicular to the rotating spinning plane of the wheel. As it tries to precess, as it's falling, it's always 90 degrees to it. That's the difference between this and those free swinging balls. I'll do a quick demonstration of the spinning wheelbarrow tire on the turntable, and just for the comparison, and we'll try the swinging ball device after that. Okay, the normal spinning direction of the swinging balls and this wheel, looking at it from the position of the camera, is spinning counterclockwise. So the normal direction of precession would be counterclockwise, looking down on top of me. So if I force it down, it will go counterclockwise, looking down at me. If I force it up, it goes clockwise. That's what I call forced anti-precession. So this works real good. You can see it in one of our earlier videos, but just wanted to show you that before I try the same thing with the spinning wheels, free spinning balls. Okay, I'm spinning it up and trying to get it as fast as I can without it flying apart. If you look at the rotation direction of the spinning ball, sometimes gets kind of weird. That's because I did all this at 240 frames per second, so that is an artifact of the video's frame speed. But I'm trying to hold it, and I'm going to try to force it up and do a forced anti-precession. Now it does, but you'll see the axle shaft is way off 90 degrees from, it's not perpendicular to the spin plane. But it does spin me around like a forced anti-precession. And I keep trying to get it to behave, and the axle shaft will bend, but the balls want to keep spinning in their own spin plane, not where the axle shaft is going. So that didn't work. Okay, we're going to look at this again in slow motion, and so you can get a better idea of what it looks like. You'll notice it's very difficult to keep the axle shaft perpendicular to the spin plane of the balls. And again, as in a normal speed, the rotation direction of the balls is always the same, but sometimes it looks like they're going the opposite because of the video frame rate. So anyway, I'm going to pick this thing up and try to get over to the turntable and try to do the forced anti-precession, which is just raising it up. Now, it's difficult to move this and keep everything stable. The balls want to keep spinning in the same plane, but they get out of whack just moving it over there. It's already not at 90 degrees to the axle. But I stand on the turntable, and I'm going to try to force it up, but it's hard because it really gets out of alignment. You can see the angle of the axle shaft to the spin plane is pretty significant. But it is forcing me around in an anti-precession type of thing. I was surprised it did that. But it totally just did not work. So this was interesting. One data point's never sufficient, so I repeated that last experiment, spinning it up again, get on the turntable again and see what I can do with it. I found that if the balls were spinning very fast, it was a little easier to get it to move me than if they were spinning slowly. And I'm not purposely putting my back to the camera, it's just where I ended up. I decided to try it again, and we'll take a look, see what that looks like. I'm trying to do a forced anti-precession up, and it does do that, but not very well. And it's already at a significant, the axle is already a significant angle to the spin plane. So, still not working. Very difficult to control. I don't give up easily, so I'm trying it again. Got it going a little faster this time. I'm lucky those weighted baseballs didn't come loose. That would have been bad. Now the axle is pretty much perpendicular to the spin plane. I'm trying to do a forced anti-precession by raising it up. But as soon as I do, it gets at an angle. It does it, but very, very out of control. It doesn't work anywhere near as well as a spinning bicycle wheel or spinning wheelbarrow wheel. Let's talk about what we learned using this, what I call this Green Goblin spinner for a spinning wheel gyroscope. If you have a rigid wheel, like a bicycle wheel, like this, or the, in this case, our wheelbarrow wheel, the axle shaft is 90 degrees to the spinning plane. It's rigid. You can't, when you move the axle shaft, that's going to stay 90 degrees to it. And that's why you get those torque effects. What we found with this spinning wheel or balls, you don't get that. What happens is it flexes. And it was possible to get a slight effect, some slight torque effects, but very difficult. Because when it's bending through like that, this spinning balls are going to want to, let's say we got it spinning like this, they're going to want to stay spinning in that plane. So when I go to try to move it through like one of my forced precession movements through an arc like that, the balls keep going in the same plane roughly. They're forced a little bit. It gets all out of whack, and when you do that, the way the chains are, you pull them in on one side and the other side, and not on these two sides, so it tries to form an oval shape spinning, and it just doesn't work. So I think probably, based on what I've seen, this is very interesting. It's actually very fun to do, but dangerous. This whole thing weighs about 9 pounds. These are about a pound each. They could clobber you if you got in their way. But maybe Green Goblin or Spider-Man might be better off with it than anybody looking at gyroscopes. But anyway, I did learn something, and hope you did too. And if you did, please click on the round Anisotropic Plus subscribe button, and check out our other links to our other videos. We'd really appreciate it. Thank you.